Okay, young people, we have just finished our quarter two assessment, and now we're going to review what we have learned. First, we talked about what are linear equations versus nonlinear equations. On the left are linear equations. Notice that the exponents do not have a variable with the, notice that the variables on the left side does not have an exponent of anything greater than 1 or less than 1. So there's no x to the second power, third power, fourth power, and there's also no x to a variable, or there's no x to a fraction. All those make that equation nonlinear. We also don't have a variable in the denominator. So we don't have an x or a y in any of the denominators. So that would make it a linear equation. If there are variables in the denominator, it would make it nonlinear. We also don't have x's being multiplied by y's, or w's by z's, or s's by t's. If you multiply two variables together, it becomes a nonlinear equation. And finally, we have nothing under the square root. If it's underneath the square root, a variable underneath the square root, not a number, if it's a variable underneath the square root, it is a nonlinear equation. Numbers can be under the square root, but not variables. If the equation y equals 3x minus 2 has a slope and y-intercept that is doubled, what would change? A better question would be how it would change. So we can actually answer both. Let's compare and contrast. The initial equation is y equals 3x minus 2. So if we doubled that, which means multiply by 2, the new equation would be y equals 6x minus 2. Let's see what we observe. We notice that the 3 has now become a 6. So we know that the larger the slope, and in this case the 3 and the 6 are the slopes, the steeper the line. So this equation, the green equation, is steeper than the black equation. And if I had added another equation, it is even steeper than the yellow equation. The black equation is steeper than the yellow equation because whole numbers make the line steeper than fractions. And the larger the whole number, the more steeper the line. Steeper being defined as closer to the y-axis. Also, we have our y-intercepts that has changed. The y-intercept went from 2 to 4 because we have doubled it. So now that it's 4, notice that the graph shifted down an additional 2 steps. When the y-intercept is 0, the line is going through the origin. When it's -2, it's shifted down twice. And when we double that, it is shifted down even more to -4. Watch It TV charges a one-time connection fee of $150 and a monthly fee for digital cable service. What is the equation and what does the $35 represent? Well, let's figure this out. There's two things that this is looking for. It is looking for an equation and a description of the $35. Well, starting with the equation, we know that there is a one-time charge for a connection fee of $150. So it's not reoccurring. So we're not multiplying that. I know that there is a monthly fee of $35. That is reoccurring at a rate of $35. Remembering our slope-intercept form, which pair of numbers were being multiplied? The m and the x. So that means for the monthly fee of $35, we're going to continue with the m and the x. and the one-time connection fee, which is being added to the bill of $150, that has to be our slope-intercept. So let's talk about what we've discovered. The slope of this equation, or the m, because m represents slope, is $35. The y-intercept, including the sine, is $150. So that means this graph is shifted up 150 steps, and the rate of change is $35. What rate is that? $35 per month. What is the relationship between the slopes and y-intercepts for these equations? Well, just like if we were solving for decimal percents and fractions, all those things need to be in the same form. So guess what? Equations need to be in the same form too. This equation is in standard form. How do I know that? It's not solved for y. This equation is in slope-intercept form. How do I know that? It is solved for y. What is slope-intercept form? Y equals mx plus b. M is your slope, b is your y-intercept. So what we're going to do is change this black equation of 8x plus 4y equals 16 into slope-intercept form. How do we do that? We're going to subtract 8x from both sides of the equal sign. Why am I subtracting 8x? This 8x is positive, so in order to move it to the other side and to keep a balanced equation, we must subtract by 8x on both sides of the equal sign. Now that we've subtracted by 8x on both sides of the equal sign, we are going to rewrite what we have left. Have we solved for y? No, there is a number or a coefficient in front of y. So we need to remove that too. When we multiply or divide, we multiply and divide everything. We add and subtract per side of the equal sign, but multiply and divide everything. With that being said, we're now going to rewrite what we have left. Negative 8 divided by positive 4 is negative 2. 16 divided by 4 is 4. Now we have two equations written in the same form. Let's compare them. The slope of the black equation is negative 2. The slope of the red equation is negative 2. They are the same. The y-intercept for the black equation is 4, positive 4. The y-intercept of the red equation is positive 4. They are the same. Wait a minute. Both the slope and the y-intercept have the same values. This is not a parallel line. This is not a perpendicular line. This is not even a skew line. This is the same line, which means it's an other. It's the same line. They tricked us. Now we're going to find the line of best fit. Line of best fits are estimates on the trend of a scatter plot is, of what the scatter plot is doing. Because the scatter plot literally has dots that are scattered throughout the graph, we are trying to estimate what's going on and what's the trend or what is it doing. In this case, this scatter plot has a positive correlation. How do I know that? Notice that my arrow here is pointing up and to the right. So that means the slope is going to be You guessed it, positive. If I was on a test, I would then look at all the slopes that are negative and immediately eliminate those. Because line of best fit is not an exact science, we are estimating. We are going to talk about regression lines, and regression lines are different. They are more exact, but line of best fit is just estimating. And then we're going to determine what or where is our y-intercept. When we pick numbers, we need to pick numbers that are reasonable. For example, if someone was to say, hey, this y-intercept is negative 57, I would say that's not true. Why? Because this line here is obviously not as steep enough in order to touch this y-axis way at negative 72. If they were to say, hey, this slope is a positive 375, I would say, no, that's not true, because this line isn't shifted up high enough in order to say it's at 375. Remember, the intercept is telling you how far up or how far down this graph is being shifted. Again, this is an estimate because it's not an exact science. This is not linear regression. This is just a line of best fit. Best fit says we are doing an estimate on what is most accurate or more likely to happen. Let's give it a go again. Hey, this line is a little different from the other line. The other line, even though they both have a positive slope, the slope is truly different. This positive slope is not as steep as the other positive slope. Notice that, however, the dots or the scatter plots that are surrounding this line is a lot closer. That means that this is a strong positive versus a weaker positive. I also notice that the y-intercept is between 100 and 150. How do I know that? Because of where it's touching the y-axis, approximately. So if someone was to say, hey, the y-intercept is 275, I would say, no, that's not correct. It's obviously not that. Or if someone was to say, the y-intercept is negative 58, I would say, no, that's not true, because this line is approximately touching this y-intercept at about 140. Here is why we learned line of best fit. If it's not exact, kids sometimes say, well, why are we learning this? We are learning this to do what we're going to do now. Predict. Predicting is a whole lot of what adults do. A lot of things in life are not easy to recognize pattern, but what we are trying to do is to predict what we can. So notice that this graph is trending in the positive direction. However, this 45 would be approximately here. So it is touching the line at approximately 80. So if someone was to say, hey, I believe in the next 45 seconds, the temperature in Fahrenheit would be 110. I would say, no, it's a strong positive that it's going to be 80 degrees. Or if someone was to say, hey, I'm going to need a jacket because after 45 seconds, it's going to be 40 degrees. I would say, no, it's a strong positive that you won't need a jacket. It's going to be 80 degrees. Okay, we are going to solve this equation. Why don't you hit pause and see if you can figure this out? Go ahead and hit pause. Did you get 10 years? If you didn't, in part 2, we're going to discuss how we figured this out.